Everybody's here. So we're starting on the first one, E2_1. Okay, so write an area tester. Again, if you don't know how to do it, you go create a rectangle object in, it's on most of these computers actually, in Java. And it's going to say, all right, graphics, how to create a rectangle, creating objects, Java tutorial, rectangle, creating an object. There's also, for instance, and then we could just like go look. And we'll show you how to do it. But again, this is a fast and dirty way of solving any problem you may or may not have. All right, so I've got these options, typically a constructor, blah, blah, blah. And I've got, all right, if I make a new rectangle, I give it dimensions and a point. So where it's going to be and how big it's going to be. All right, that's a start. So class name, object name equals a new, that's the key when you say make a new one. And then it has to be the constructor name, and then in parentheses any parameters that are required. And again, if we're not sure, and for most of these, once you use them once, you're not going to have to do this again. We can always go to the official Java list, and you come over here and you find the class right here. And they're in alphabetical order, so we're going to go down, we're going to find a rectangle. And I'm having trouble with my alphabet. Rectangle right here. All right, and we want to find what these numbers mean. So we come down here and we find our constructor. I've got one that says x, y, width, and height. So if I use this one, I'm going to give it 4 numbers. The first one is the x coordinate. The second one's the y coordinate. And unlike a algebra coordinate plane, you can treat this like your screen. In the upper left corner is 0 on the x and 0 on the y. And they are just positive numbers from there. Okay? So I'm going to use the class name, give it a name for create an object, say new, and then give it the required information. Okay? So if in BlueJ, what we're going to do is we're going to create a new project. You could do this all in chapter 1, but I would split them because these are going to get pretty big. So I would say new project and put it in a file folder that you can go find. I don't care where you put it as long as you can get to it.
Well, I'm doing it on this, like how do I get to it? Can I email it to myself?
Well, if you get it to that, you can save it, you can upload it to your Google Drive, and then you can get to it anywhere.
Okay.
All right? So I would, anytime you make a new project, you should call it your name. The folder name should be the name of the assignment. Okay? So E21, and for me, it's going in my APCS folder. For you, it can go wherever you can remember it. Okay? And when you create it, you're going to get this blank one. And you're just going to make a new class. Now, based on the assignment, what's the class supposed to be called? An area tester program. So I should call my new class area tester. Okay? And it's going to come up with this area tester. I double click. And remember we said you're going to wipe out everything in the middle. It's going to look like this. Okay. Author becomes your name. The version, okay, should be when you're doing this assignment. So today is 9/22, right? Yeah. Then you should add one at assignment, just so in case you put the wrong, because when you start uploading 2 or 3 of these for one assignment, you're going to want to. That better? You're going to want to know if you put E27 in here, I'm going to make, all right, you just put the wrong one in the wrong place. So then do that. And then the last thing, if you worked with anybody or you found this online or anything, just put the name in there, okay? So we now have a class called area tester, and this is the only class that I'm creating. So this needs to be my runner. So what do all running classes need? Who remembers the one thing that they all need, or they're not going to work?
Public static void.
Public static void.
Oh.
One more word.
Main.
Main. When you run a program in Java, it looks through all of your code and looks for the word main, and that's where it starts. That's the first line of main is the first line of your program. So we're going to write public static void main string args, and do not worry, by the middle of winter we'll understand what this means. For now, just know that you got to put that in there to start.
Do you usually do both your brackets before you start writing? Like the, I don't know.
You don't have to. BlueJ will automatically put those two in there, so it doesn't matter as long as they all line up, right? So what does this assignment say I need to do? It says I need to make a rectangle object, and so rectangle, to make an object, I have to use that line we just came up with, right? Where I write the class name, right, which is my blueprint. And all rectangles are the same, except objects have to have a unique name, right? So I can make 1,000,000 rectangles in this computer program, but they all have to have a different name, otherwise the computer can't tell them apart. All right? So when you make an object, you call the class name. What is the type? What is it? This is a rectangle, okay? What name do we want to call our rectangle? It could be whatever you want. Technically, it should be a name that makes sense. So maybe George isn't the best one. Maybe box 1. You can call it George, you can call it Andy, I don't care. Now, this tells the computer I want a variable that's going to be a rectangle type. Okay? And it's going to, and now it's got a name, but the computer will not make a new one until I say new. Okay? So you're going to write the keyword new, and if you notice in BlueJ it changes colors. Words that you can't use on your own change their special colors, okay? You can't have a variable in your program called void. That is a very specific term. That's why it's red. You can't have one called new. New has a very specific set of instructions. All right? And now I'm going to call my constructor method, which has the same name as my class, and it has parameters. Parameters are starting information that this program needs. So make a new rectangle and give it 4 things. Now, does anybody know, based on these numbers up here, I have an x, a y, a width, and a height, and they have this int in front of them. What does that mean? Integer type. Anytime I have a variable, I have to say, what is it? Okay? We're making a rectangle. I need 4 integer numbers to create a rectangle in the computer. What is an integer? It's like Algebra 1. A number, a very specific kind of number. Whole number. All right? So I can't, so the first number I put in is the x coordinate. I can't say 0.25. It's got to be a whole number. I don't, this is a coordinate grid on your screen, and it can't be, I can't have half a pixel. These are pixel numbers. I can't split one. So I need an x, a y, and then a width and a height. Okay? So what do we want? Where do we want the first, where do we want the x corner of this to be? Give me a number. 10? Why not? Comma. What's the next number? Give me a number. 15. The y value is going to be 15. All right, Finn, give me a width of this rectangle box. 5. All right, Scott, give me the height. 7. All right. Does that look correct? Does that match what we said up here the method call needed to be? An integer, an integer, an integer, an integer. Now they are specifically in this order, the x, the y, the width, and the height. So if I meant for my height to be, or my width to be 15, right now I put it in the wrong place. But semicolon says, that is one statement. Boom. Now when I run this, I will have made a box. Now it doesn't draw it, it's just a coordinate system in the computer. But it now goes in the computer memory somewhere. You don't care where, the operating system picks, and it blocks off memory, and it calls it box 1, and it puts in these 4 numbers, and it saves it. Now anytime you want to go get it, you can go get it. Now, what things do rectangles know how to do? Well, we've got all these methods. These are all things that rectangles know how to do. We can add points to them. We can check whether or not it contains a point. We can create an intersection. We can get the bounds. We can get the height. Oh, okay. I have these gets, these methods called get. Does anybody remember there's a specific term for methods that give you information? It was in your reading.
How far in?
Not that far.
Set, maybe?
No. It's not. It's the opposite. It's not a setter because I'm not. Am I changing anything if I get a number? No. It's not a setter. It's a getter. Get, also called an accessor or a mutator, right? This accesses information. It goes in the computer and finds the specific information relative to this box and gives it back to me so I can do something with it. All right. How do I create the area? And I'm sorry, how do you pronounce your name?
Mine is
Hui? You pronounce it Hui. Okay. Are you following along? Or are we a little ahead of you? Or we'll get them started on this next project, and then we'll back up for you, okay? Does that sound good? But Hui, how do you calculate the area of a rectangle?
1/2
1/2?
the base times the height.
Base
The base
times the height. So what's my base of these four numbers? Which one's my base? I've got a width of 5. But I mean, we don't know if it's turned. But so one's 5 and one's 7. So what's my area? 35, right? I just multiply them together. It should be 35, right? When I get done with this, the computer should spit out 35. Now, how did you get 35? Multiplied 5 and 7. Now, I don't want to use 5 and 7 in my program because what if my box had a different number? You never want to hard code information. I don't want to say something like this. I never want to say like system out print the area is plus the math 5 times 7. Because what if my box isn't 5 times 7? This program's not going to work. How am I going to get the value associated with a box? The boxes know how to give you their height.
Get height.
There's a method that goes and finds it and gives it to you. Okay, and it's called get height, and the other one's probably called get width. So they're already written, so I'm going to use them. Now, I have a get height method, and I'm going to call it like that, right? Methods without parameters, empty parameters to tell the computer this is a method. Now get width.
Why do you need the two?
The parentheses tell the computer this is a method call, but a method call that doesn't require you to give any information. There are no parameters. It's just the syntax for a method call.
So what if you didn't have those? What would happen?
I don't know. Probably going to get lots of errors. To say, Dad, you need something else there. All right. Now, I'm going to put a semicolon here. Now the question is, if I did this, all right. Now, when I say tell the computer to print get height times get width, how's it going to know which one to use? Stupid computer. It's not going to know. What can I do? What do I have to do?
Get height 1, get height 1, something like that.
I got to call it. If I want Scott to answer a question in this class, what do I have to do? Say, Scott, answer the question, right? Scott's not going to know how to answer the question otherwise. You have to identify which of your objects you're telling it to do this work on. So you call the object name and then you put a period. And then this tells the computer when it runs it, go find box 1 and call this method that it knows how to do because it's a rectangle. Now, it's going to multiply these two numbers. And we'll see if it prints it. All right. Now, if we go to compile, we're short another one. Whoops. Control Z is your friend.
So box 1 and box 2 are classes, or they're objects?
Objects of the rectangle class. They're both rectangles,
Okay.
but they each have a unique name.
Well, box 1 not get height is saying is basically do the get height method on the box 1 object.
Now, if you go to compile it, you're probably going to see this error. It says, I don't know what a rectangle is. Okay. Now, rectangle classes have already been written. All right. You don't get to change it.
Do you need to write Java for compiling?
You need to do what's called an import. When you start Java in BlueJ, it brings in all the common commands, strings, things like that. There are thousands of classes that have already been written. It makes your programs very bulky to put them all in your program if you're never going to use them. So things that you don't always use, you have to do what's called an import. All right, and you will import above your class. And, well, we'll do it properly. Technically, you write it above any and all comments. You write import, and again, it turns red, right? That's saying this is a word that the computer recognizes, and you can't tell it to do anything else. And you're going to tell it where to find this class. So in AWT, which is a subset in the Java library, now it's going to go put it in your file. Your file is going to be a little bigger because now it has rectangle information. And now I'm going to compile, and now I've got no syntax errors. All right? So now I'm going to close this and try to run it. And what do we think it's going to do? Run, click on void main. We're not giving it any parameters, so just hit enter. It says the area is 35. Is that what we expected? Yeah. It's 5 by 7 rectangle. It should be 35. Now, anytime you have the computer do some work for you, you should do the work by hand like we did so you know if it's working right. If we never did the math and it said 35, well, I don't know. Sure, 35, or why not? So you need to put in expected output inside your tester. So after the line that the computer does the work, you're going to essentially do the math by yourself and then see if they match. Okay? And then we compile and run it. It's going to look like this. So the area is 35, the expected area is 35. Then we know that it's doing the math correctly. Because what if it did what if we got like this answer? The area is 12, the expected area is 35. What is that going to tell you? Something's wrong. Now, is this a logic or a syntax error? Logic, because did the program run? Oh, the program did exactly what you told it to do. Now, is the program doing what you thought it should do? No. So what's the problem? So this is why you need to go, if I multiply those two numbers, I should get 35. I got 12. How do you think we got 12? What do you think we did? How do you think we got 12 instead of 35? Oh, okay. Oh, look at that. We put the wrong symbol down in here. We're trying to tell the computer it should multiply them, and I hit the plus symbol. Ah, so this is why you want to check that your answers. Computers inherently stupid. They will blindly do exactly what you tell them to do. And if you tell them to do something wrong, it doesn't know that the word area means you should multiply. If you tell it to add them, it's going to add them. So you need to always check yourself. So. Okay. Now, have you gotten it to look like this, where you compile and now there's no errors? Yeah. So on a non-PC, you right-click. You have to do whatever the Mac equivalent of right-clicking is, and then you come down where it says void main, and then that says run it at the main program. You're going to click on it, and you're going to get this box. We're not giving any parameters, so just hit OK, and it will run it. And you have an operational computer program. That is nice. So what I want you guys to do is try this program, E72. Okay? I want you guys to all work together for a few minutes while I get Hui set up and started, okay?